Actually, I'm educated a toolmaker. My parents had an injection molding company, and one day at a fair we discovered this new technology 17 years ago. I think it was in 94, we saw it, 94, 95. We saw it the first time at a fair in Germany, and then I just fell in love in 3D printing and took it from there. There was actually no market because nobody could actually do 3D drawing. We had 2 or 3 customers that could make the 3D CAD themselves. So in the beginning we had to do a lot of 3D drawings. But now you can download Google SketchUp and you can have it for free. Sit at home and make some design. Well, the first thing we do in the morning is verify all builds that has been building during the night, because it's very important for our customers to get it very fast as soon as it's out of the machines. And then we take a look at the incoming over the night from the areas that is not in the same time zone, and start doing quotes. And around lunchtime we restart all machinery and do the next day production. It's primarily the medical industry and the household industry, appliance, automotive, cell phone, toy, so all industries actually. Here in our facility we have what we call stereolithography, that is a UV cured resin. Then we have a polyjet, that is an inkjet printing system, and selective laser sintering, that is a plastic powder based system. So in total we have 3 different technology groups here. There's of course some other technologies available. You can print in metal, do very complex metal parts for molding. There's some plaster printers and other low cost printers, but actually the very good printers is located here, the ones with the high accuracy and that really works on the day-to-day business. The easiest is of course if they deliver a 3D CAD file, and it does not have to be anything very complex, just something out of Google Sketch or some other free systems, or maybe some of the more expensive systems, ProEngineer, Unigraphics, and the high-end CAD systems. So we actually take everything that is in 3D. These machines are, the cheap machines are going down in price, and they are very close to be at what expensive normal printer costed maybe 20 years ago for a household. So you can have a small simple printer for 5,000 Danish crowns, so very cheap, around $1,000 US. And the larger systems is of course in millions of Danish crowns, so they are not that much for the household. So of course the one is that you do your own toys, small spare parts at home, and then the other part is that these machines are also made better and better, and the materials are better and better, and we go further and further into low volume production. So where you have individual parts that is produced, or a small series of parts. A very good example is in the hearing aid industry. The in-ear shells that is used is in 90% of all shells printed on a 3D printer. So it's printed individual after a scan from the inner ear, and then the electronics is put in, standard component electronics is installed. First thing is, how does it look? Of course you can see that on your 3D screen to some sort, but you do never get this, how does it feel in the hand, how is it to hold it? Is it too heavy, is it too light? Do you get the good feeling of it? And when you have that, and finish doing all these initial print, you start with all the technical prints. The cup is not the great example for that, as if it was a medical device. But here there could be something in, what about the card box that you go into? Do you also want to try to print that and see if you can have some nice displays printed at the same time? What would it look like? So normally it's more loops than one. All projects are top secret, no matter what, because it's very important for the customers. Some of our customers is releasing their products we're working on now in 2-3 years. So it would be a catastrophe if somebody saw it at this point.
Yeah.
So everything's very secret. In Northern Europe, we are around 3 or 4 companies like this in different sizes. And then if you go further down into Germany, there's some larger companies in the automotive areas. So it's a very small community of printers. Play. Play is the only thing you have, because this is not an education you can take in how you have 3D printing working, and if you can find something where you do it's very specialized into just one process. So you have to try to see all these different processes that are working differently. And the only way you can learn them is to play and try, and when it crashes all over, you try again and again and again. And it takes some time. The first technology that we saw was stereolithography, SLA is it also called, or SL. And this is where you have a bath of liquid photopolymer in epoxy base normally, and have a UV laser that cures layer by layer. So you actually glue layer by layer on top of each other. The second technology we saw was the inkjet technology from Objet, Polyjet. And this works like a regular inkjet printer, so it has nozzles that drops out resin drops, and then it has a UV light that cures the drops that came out in the right position. The last technology we have in-house is laser sintering, or selected laser sintering, where you melt plastic powder, that is real plastic powder, nylon powder, layer by layer, and get very tough parts that really can withstand a beating. The speed of the processes is that if you print one part, the Polyjet process, the inkjet process, is way faster than anyone else. The stereolithography is right after that, and the sintering is at the end. But if you multiply parts and build maybe 100 parts, then the sinter machine wins due to the bulk production you do in laser sintering. My name is Jesper Damby, and I'm the co-founder of Damby Develop Rapid Prototyping Solution.